Right, class. So this is equivalent forces. Equivalent forces, you have this what they call 2D frame coupling system. Equivalent resultant force and coupling moment acting at A, and then the equivalent single force located along the beam AB. Now you have three forces. You have a 35 force at 30-degree incline to the vertical. You have the 20 coming down straight, and you have the 25 going horizontal. So you have three forces. Now the 35 that has an incline has a component horizontal and vertical. Now those are the two that is most challenging. So you have to resolve one vertical, one horizontal. Now it says a plan of action. You must find the sum of all the x and y component of the forces to find the resultant force. And then it says find and sum all the moment resulting from moving each force to A. Now you notice where A is. And you have to look at the position where A is and the position of the three forces. Now the final part is where you're going to shift the resultant force to a distance D such that D is equals to the total moment, resultant moment divided by the component of the force in the y direction. Not the resultant force. Most important thing you need to understand right here, right? When all is said and done, that's important. That you can make a big mistake by using the resultant force component there, but you're not to use the resultant force component there, right? Your note, please use FRY. All right. Now, let us go back. All right, to the next slide. So, as you can see, the resultant force, let's look at them first. The sum of all the resultant force in the X. Let's examine it carefully. Now, for the 20 force, see it here? So you have one here horizontal. That's the first one. The next one you have is a component here that is going to be horizontal. So you have one vertical and one horizontal. To get to this direction, you must be going to the positive X axis, right? So let's see if I can pick up a writer there. All of these things are scrolling one time on me, but hold on, please. So all right. So let's pick up a writer. So what I'm saying here, look at this component here. Let me just expand him up here. So a component is going down. You have the vertical coming down, and they really know that the angle between here is 30. Now, you have a component. In order to get to that point, you have to go in the x direction and then in the y. So you get two directions you're going. The component that we are interested in, remember this is the resultant, it's acting like that force, 35 force. The force that we are interested in is the component here. If you look at the angle is pointing towards that direction, so it means that is a 35 sine 30, and it is positive. So therefore it is 25 plus 35 sine 30. Those are the only two components that we have for the horizontal. The next one now, and you know it's a convention here, the equilibrium equation here, going to the x direction, sum of all the forces going in the x direction equals to that. And to the vertical now, let's examine it. So we have one component coming down here, which is negative. So it's going to be 35 cos, negative 35 cos 30 coming down. The next one we have is this guy here. So it's minus coming down also, and this one. So they give us 42 for the resultant for the x, 42.5 pound force. And this one is minus 50.31 pound. Now, what about the taking the moment, the resultant moment? What we're going to do now, we're going to look for each component and we're going to take the moment to see, assess them to see whether or not they have a moment there or not. Okay, so we're going to start with the 35 component in the Y. So this 35 component is coming down. Now, where is it coming down from? 2 from A. Everything is going to be related to A. So it's going to be coming down here, about the distance here. Now, where are we going to move it? If you're going to move it that way, you're going to move it in the clockwise. Now, the clockwise, our convention that we are using, we are saying anti-clockwise is positive. So if you're going opposite direction, it's going to be automatically minus. So it's minus 35 cos 30, and the distance is 2. All right. The next component that we have, we'll consider, right? And question, why is it that I'm not considering the horizontal component here? The horizontal component, 35 sine 30, is running right through this, so there's no distance. So it cannot be a part of it. It is running right in line with A. So we move on to the 20. The 20 is now at what distance? 6. 2 plus 4, 6 from there. And it's then now it's turning it again into the clockwise. Can you see that? So it's 20 times 6. So it's minus also. What about the 25? The 25, now here's a perpendicular distance. It must be, it's a transmissibility of forces. It's coming right through this point here. So it's 3 from here. From A to this point is 3. And then it's going to be turned into the anti-clockwise. So therefore it's 25 times 3, which means it is positive based on our convention. When you work out all of this, you'll get minus 105.6 pound force. All right, that's done. Now we can find the resultant force. Or you could even put the sum of the resultant force. Sum of the resultant force you use in Pythagoras theorem. You're squaring these two quantities here. So you're squaring this and you're squaring this. So it's 42.2 square plus 50.31 square, and you take the root, right? And you get 65.9 pound. Now, of course, the force, when the resultant force acting down, we need to know the angle in which it acts down. How do you? So we look at the components here, these two components up top here, both FRX and FRY, and we can formulate a little triangle. So we look and we see X is positive, so it goes positive direction first. And then we see Y being a negative, so we can turn it down. All right. Now, if I turn it down, we can close the triangle. Now, the angle subtended is this angle, right, that we want. So we want this to find the angle that it turns down. All right. So it is 42.5 here, and it is 50.3 here. So from that, we say that the tan of it, pardon me, tan is really equals to the opposite, which is 50.31 divided by 42.5. So it's tan divided by the adjacent. So, and you take the tan inverse and you get 49.8. So that is how it goes. So you go, that's a direction. Now this is direction of the resulting force that you want, right? We don't necessarily find it yet. You see it on the diagram, but it's that, let's say you don't reach that stage yet. You get the component of in the X direction and component in the Y direction. And from that, you are able to find the direction of the resultant force. And you just consider, say, you don't know it yet. And well, let's see, actually we have it here because we did the Pythagoras. So yes, really indeed, we do have it. It says the equivalent single force can be located at the, so we need to find out where is it located from A now, along the beam, AB, at some distance D. Now, we already know that moment is force times distance. So let me explain clearly what is this line saying up top here. The line up top here is saying that, one, we know the moment, the resulting moment, and we just found it, which is minus 105.6. Huh? it is that. So it's going to be some distance from that times some force. Now, as I pointed out before, the force that we are interested in is only force in the vertical, no force in the horizontal, because we're only interested in the vertical force. So it is not the resultant force you're going to use FR. You're using FRY. Please note the difference is FRY. So getting D is just a matter of transposing, dividing the moment by D. And you notice D is up here, big and bold, 50.31, right? And when you divide them, you get it that it is 2.10. So we are saying, in a sense, it is really 2.01. Now, it may not look so in the diagram because of, not to scale. So this is 2.1 force, right? So that's the explanation for that, all right? I trust that you understand that, and that brings some clarity. So we find one single resultant force that can replace everybody onto the beam, right? And in doing that, we had to do it through different processes, right? Now, this is one that I did in class, and I've also put some clarity on it. So for all of these forces, all I did was just break them down into terms of the angle. Rather than having the ratios, I find the angle which is 36.9, and for this one, it is 53.1. So the same force hanging down here, right? And this one coming down. So I take them one by one and we look for all of the components. Components, first we look for all of the X components. So the X component will be this one, which is negative. So that will be 150. No, that will be 100 cos 36.9. Ignore up top. Let's work with this that I've worked out here. So that is, and it's going in the negative. So it's minus cos 36.9. All right, in fact, let us do both of them for this. So we'll have to come back for the 100 force. And then for the vertically coming down also, minus 100 sine 36.9. So we have two components here, one in X, one in the Y for the 100. What about the 150? Let's leave the 50 alone for last. For the 150, it has two components, one in the X, one in the Y. So the one in the X, it's also positive. So it is 150 cos 53.1. And for the vertical, coming down, I say coming down, you're going that direction in order to get to this point. So it's going to be minus 150. Sorry, it's going to be coming down is minus 150 sine 53.1. When you work out those, you get 90, 120. When you sum all of the RXY, you get 80, minus 80 plus 90 plus 50, you get 60 pound. And for FRY, you get minus 60, minus 20, you get minus 180. So those you have, so you can simply find the resultant force by using Pythag for the 60 and the 180. All right, let's move on. Now, I must note to you that for the 50 force, if you notice 50 force only have an X component. So we see we had it right here. So it says 50 only. So it has no Y component. So all of those are all the X. Now, all right, now that we have found those, right, we simply can go ahead and we find FR, which is what, say square the 60 plus the 180, I get 190, huh? Simple, all right? So you get 190, all right? Now, what about the angle? The angle again, show you how you find the angle. The angle comes down, right? And this is the component for the X and Y were well, let me back up there. I'm just going a little bit ahead of myself there. The component for the X is positive, so we can see that line. And for the Y, it is minus again, 180. So we draw it. And the angle we're interested in is that angle, right? That this force here is coming down. All right. So it's going to be simply the using tan, which is going to be the 180 divided by the 60, right? And you get 71.6. So that's how you get the angle. And you go through the process again, using the same formula for D, take all of the resultant force, which is in this case -1, it's really minus 64 divided by minus 180. I don't know, I've left off the minus there. And when you divide that, you get 35.6. So we're saying that some distance 35.6 from A is that distance D. So D is represented by that distance right here. All right, so that is simply what you should understand. Now, for clarity, let me just remind you how is it that we actually got the moments. Let's go through the moments part again. Last week we did it, but it wasn't clear, I think, to some of you. So we said that, look, it has two components. One is 60 and one is 80 for the 100 force. When you're taking the moment using the sum of the moment in the anti-clockwise is positive, right? But we're not gonna say equal to 0 in this case. It's trigonometric equation we have in the subject matter. Sum of all the forces in the x is 0, sum of all the forces in the y is 0, and the sum of the moment is 0. But when you're doing equivalent forces, we don't necessarily say that it is equal to 0, because we actually get a value down here for principle's sake. Now, when you're taking moment for the 60, the component of the 60, it's going to be coming down into the clockwise direction, which is going to be minus times the distance, which is 6. So, right, so it's 60 times 6. And for the 80 is coming this direction, and it's going to turn about this point here. Notice the distance from A to up to where the 84 says is 1. So it's 80 times 1. Now, and it is positive because it is anti-clockwise direction. It's going to tend to be turning it this way, right? And some anti-clockwise domain there. Marker that way. Refuse to write. So it's turning it in that direction when the force is going to be coming across. You notice this purple looking line is going to be coming across here. So you're going to turn around this point into the anti-clockwise direction. So those are the two. What about the next component? The next force here, you have two forces here, two components here. One is running straight through A, so it's not a part of it. That's the 90. But the 180 will tend to want to do some turning it. Where's it going to turn to? If a pivot point is here and the force is here, it's going to be turning it clockwise. So it's therefore minus 120 times, what is the distance? 3. Right? So it's coming down. Remember now, for those persons, it's coming down. So it's going to tend to spin it against so it's a force against the distance, which is 3. And equal to minus 640. So if everything work out there, you get minus 640 for your moment. As a sum of your moments, sum of the total moment. Now, what about the 50? Why is the 50 not a part of it? 50 running right through A again, as I said it before. So the clarity, see them all here. These are all the components that we found before. And all I did with the components, both the X, Y, we assess them to see if they have moment about the point that we are interested in to find that single resultant force. So we say that when we had them, different components, component X, component Y, we get those values. And we simply divide the total moment by FRY, this guy here, not the resultant force, but that, and you'll get that single. So the intent is to get the single force that is acting from A, and we show you before, and we show you how to get the angle and all of that. So that should be simple, and everybody in the class now should pretty much understand that. What about this guy here? This guy it's the same thing. Let's just see what is it that they're asking us for. You have a 2D frame, equivalent resultant force, coupling moment acting at A. All right. So you find the components. I must find the sum of the moment resulting from moving each force A and add them to to the 50, right? So whatever, when you finish with find your Moroccan force, you're gonna add the 50 to it. And you're gonna do the same prints and you find, right? So that's what it is asking. So, yes, so you sum all the components of the forces. So, unlike before, just like before, let's look at all the forces that we have to contend with. So we have two forces. So this is pretty straightforward. So look at that force there, the 150 force. The 150 force is going up that direction. And so you're gonna have a component that way, a component this way. All right. So this is a 5-4-3 triangle, and this is a 150 going up. So what's the angle here subtended? If we want to make life easy, we can just find it. So the cos of ratio 4.5. Cos of ratio 4.5 is 4 divided by 5.8. So the cos inverse of 0.8 is 36.9. So we put in 36. I'll make everybody life easy. 36.9. 30, pardon me, that's incorrect. Let's clear that up. That's 39. We have 36.9. So it's 36.9. All right. 36.9 right there. Um, hmm. So you have two components. So we can use the trig ratio, make life easier for everybody. So you can say that this is 150 in the x cos 36.9 for that component in the x. That's what the 150. If you call that for f1, and then the f1x and f1y, what's that one now? It's going to be, is it positive too? So it's 150 sine 36.9 in the positive direction. So you have two components here. Now, what about the 50 component? Let's analyze that one. 50 component is of that direction. It has a component in the x, component in the y. Both of them seem to be positive, right? So they are, where's the angle subtended we're looking for? We have to be careful with this one. It is actually up top here, not on the bottom. All right. So we are saying that this is 50. So the component here is a sine. For x is a 50 sine 30, and the component here is 50 cos 30, and they're both positive. All right. So now that we have 4 components, we can assess them. So we say that now this, I've actually worked out this one in the ratio 4.5. Now 4.5 is the x. So the x one, as we had said before, right? So the equivalent to this one is the 150 cos 36.9 for this one, right? So this work out to 36.9. So it is cos 36.9 times 150, right? And we already said that that is the x. All right, where's the next x component? Next x component is the 50 sine 30. So the 50 sine 30, add to that, give you 145. The next one, all the y's now. We have one y up here. Where's that y? The y is right here, 150 sine 36.9, which is actually going up. So it's positive. So see him here. So that is sine 36.9 if you don't want to use the 3/5 ratio. Plus the next x, the next y component for the 50. The 50 is coming right up here. So it's 50 cos 30. Now you add those two together, right? And you can you add all of those two, you get 133.3. All right. Now to find the magnitude and direction of resultant force. So the resultant force, you're going to square the two components, use Pythagoras theorem. And the next thing is to find the angle at the act. I tell you already, how you do the angle. Let me sketch this down here. Let me just see what next if I have space. All right, the angle. Let's do it up top to explain the angle. Angle again, you look at the X and Y component, you see that one is 145, all right? And the next one is what? 133. So you know that I'm going up right angle to each other. So one is 145, and the next one is 133.3. Now, so you need to find the angle subtended to it. So you're finding that angle. So see, so the resultant force will be acting up. All right. So what we do now is you're going to find the tan. See, the tan is opposite. So it is going to be 133.3 divided by 145. And that gives you 42.2. And we already see it. See it here with the angle turn up. Now the moment, what about the moment part? That is now the part that you may be a little bit challenged with. So we look for each component again, and we can start anywhere we want. We're going to start with the 150, and we're going to start with the X component. So the X component, you look carefully. Where's that X component? 150 cos 36.9, same thing as 4.5. So it coming along here, it's acting here. It's acting there actually, the X component. And you know, so it have a Y component. And seemingly, they are all positive. So one is going that direction. Now, where is it acting from, and where is the point that we are interested in? Let's review and check the point. Which point is it that they're acting at A? Right. So they say the coupling acting at A. Says at A. All right. Most importantly, now that is acting at A, right? So you're going to be one. You're gonna look. You're gonna see the force, and it's acting at A. So what's the distance of that force from A? Is 2. So where is it going to turn? It's going to turn in the clockwise, so it's positive. So it's 4.5, or you could put 150 cos 36.9 times 2. All right. What about the other components now? What about this component coming down? The vertical component running right through A, so it's not in the problem. That's what the 150. So I finished with 150. Let's go to the components now of these two. So you have one that is going in the X and one that is going in the vertical. Those are important. Now, the horizontal component for the 50 is 50 sine 30. So 50 sine 30, right here, coming through here, and it is acting from where? From A, so it's 6. So it's coming through here, and so it's 50 sine 30 times 6, and it's going to turn it into the anti-clockwise direction. So remember now, the force is coming through from this point. There's most likely going through here. All right, it's going through that point, and the distant, perpendicular distance is 6, and it then intend to turn it that way. So we're going to turn it into the clockwise. So it is 50 times 6. Now, what about the vertical component? Vertical component, remember transmission, miscibility of forces. So the line is tending to act through there. Right, the force continue. And what is the distance from A when it continues to act? It is 3. So it's going that way, but it's going to turn it where? Clockwise where it is minus. So it's minus 50 cos 30. And then now, the last one that you need to add to it is this component here. But this direction this guy going. This guy is going in the anti-clockwise, which is positive. So you add it to everything to get the resultant moment, which is 760 pound force. Now, you finish with that, all right? That's what they ask you to do. They never ask you to get that distance from A and so forth, but you could actually apply the distance that the resultant force is acting. So maybe a class exercise is to find the distance from A where that resultant force is acting. Distance from A where that single result, find the magnitude. So we already have the single resultant force. So if we were to do that now, the single resultant force would be Let's just check that. Mhm. So in this case, you couldn't use FRY, you'd have to have FRX, seeing that the frame is vertical, right? Um, or could you use it? Use it because it you have a total moment and you could find it. So you have a wide frame. The frame has a horizontal 3 feet, not just a vertical component. So you could still use a Y. So use a Y to get um, 133. 5.7. So it's 5.7. If you're relating it to A, it is acting 5.7. Um, right. And now it is 6 coming up there, so it's 5.7. It will be acting along from A. Okay. All right. I trust you understand that. So we're actually seeing it acting a single resultant force, which is the what's that called, 196. And we see where it is. So it's going to be some line onto to here. And its distance is going to be from here to down here is going to be 5 point something. If you divide this by 133, you get 5.7. So it's somewhere down here from here, right? Now, taking a moment might be the most trickiest part. What about this one here? This one, pretty much similar, has a little bit more intricacies. It has some smaller distances, which make it a little bit more challenging, right? So you in the class, maybe this is a very good exercise. Person could actually try and see if they could do a problem like this. We have a solution, but actually to give you a chance to work it out and see if you actually got it and what was your major issue, rather than explaining that one. All right. So I won't explain it. I'll leave it there for discussion. Now, all right. So there's one there for classwork, but I also need to find a classwork. All right. So that is it for now, guys.